at this one here. This is Hide and Seek, Post-Exploitation Style by T.J. O'Connor and Tim Tomes.
So let me be the fourth or fifth person here to welcome you to Shmoocon 2013. No snow. It's beautiful outside. No snow again this year, so we're all thankful for that. This is the hide and seek talk, so if you found yourself in the wrong room, please stay, because we think we're going to have some fun here. All right? As this fine gentleman just said, my name is Tim Tomes. I'm a senior security consultant for Black Hills Information Security. I'm also a security blogger, most notably paul.com. I cross-post some of my stuff to landmaster53.com. A veteran of the U.S. Army, Christian, and I love to code. One of my most recent projects is the Recon NG framework. Some of you may or may not be familiar with that. It's new. I encourage you to check it out. There's my Twitter handles up there. Please keep an eye on that for future updates to this and other projects. Here's TJ.
And I'm TJ O'Connor. Pretty much what I do for a living is fall out of airplanes. Someone please hit that guy with the shmoo ball. All right. I also just authored my first book, Violent Python. Someone can have a copy. And I was the course director of computer exploitation at the United States Military Academy at West Point. And Go Army. And I'll hand the mic back to Tim.
So we're going to get this thing started with a quick video.
This is in real time. I'll create a GUI interface using Visual Basic, so you better drop my penis.
For those of you that didn't hear that, she said she was going to create a GUI interface with Visual Basic and try to track the something or other by IP address. Okay? All right. So this film is good for a couple ways. One, because it breaks the ice pretty good. It's funny. It shows the ignorance of American television. But the second thing that it does is it presents the important point that hide and seek is still alive and well, and it's not just a kid's game anymore. Okay, so we've all played hide and seek before, but let's quickly review the rules. All right, so you got one or more people called hiders, which attempt to conceal him or herself, and you have one or more seekers, which attempt to find those hiders. Right? Very, very simple. All right, but this concept can be applied in many different ways. Right? You got the simple kids game where the one kid counts to 10, the others go and hide, and they try to find them. Right? But there are other ways that we can apply this. What about the DoD's attempt to track down Osama bin Laden, or the DOJ's attempt to track down child sex offenders, things of that sort, much more serious in nature, but some of the same concepts apply. Now this is a more modern, much more advanced version of hide and seek, and that's the type of hide and seek that is going to apply to today's talk. It's our focus for today. So the rules are the same, but the game is much, much different. It's no longer a game where we only have ourselves as tools. We have a lot of other things at our disposal. We play in this new digital playground where the hiders are concealing themselves amongst the bits and bytes of the internet, and the seekers must find them there. Okay, so what are some of these methods for hiding in this digital playground that we call the internet, right? Well, we've got stuff like onion routing. Show of hands of those of you familiar with Tor. Show of hands of people that use Tor. All right, good deal. Good number of you. So you know what I'm talking about. Anonymous proxies or open web proxies on the internet, right? We can just shovel our web requests through these open proxies, and they're attributable to something, but hopefully not us, right? SSH tunneling and virtual private networking, kind of the same concept here. We're going to pivot through a remote location that we either do or don't control, depending on the situation. And then probably the weakest version of this is user agent masking. Right? We can change the user agent of our user agent, and then hopefully trick somebody into thinking that we're something that we're not. Okay? But all these tools have been around for quite a while, right? We're all pretty familiar with these, right? Not much new here. So the hiders have some options for concealing themselves. We just covered those. But what about the seekers, right? What technologies do the seekers have at their disposal to leverage against these hiders? Well, we've got technologies, really neat new technologies like HTML5 and stuff that's been around for a while, like Java. We're all intimately familiar with Java. HTML formatted emails. We've got client-side things such as PDFs These are payloads that can be delivered client-side. We have client-side technologies and softwares. Things like our browsers, the actual activities, the things that these software do in the background that we can leverage to try to get this type of information to find these hiders, right? And obviously, some of this stuff requires post-exploitation. We have to have some level of access to the machine, and we're going to cover how that stuff works. But these are all the different technologies that the seekers can leverage to find these hiders. Okay? Now, why this technology exists, quality tools to leverage it don't for the most part. And if they have, they haven't been developed nearly as far as the hiders tools have. Okay? Right now, the hiders have a significant advantage over the seekers. And me and TJ are trying to change that today. Okay, so on the last slide, we looked at some of the options that the seekers have as far as technologies go. And in order to foster some of that, the use of all these different technologies for one purpose, we developed a framework to support them. Okay, and we call it Honey Badger, all right? I don't even know where the real name came from. It just kind of came into our heads one day. I don't even think we named it. I don't think I named it. Somebody just said, oh, Honey Badger. I was like, okay, cool. All right, so here it's a server agent architecture. Ta-da, we've got this server that's out there on the internet somewhere, and then we've developed these agents that leverage all those different technologies and call back to this server with either the geolocation data or information that can lead to us getting geolocation data, and we'll cover more about that as this goes on. All right, and this stores the result in the Badger compliant cloud. So for those keeping track, that's 3 drinks, all right? No cheating, all right? All right, so the different technologies, we had to come up with a common standard for which that they all had to comply with so that they could communicate back to the server back and forth, and everything supports web, right? So we figured, hey, we'll just create a really simple web service and develop a little API around it, and all these different technologies can just call back to the web server over HTTP. And so that's what we did. We created a little really simple API, and what does this API expect? Well, first it expects you to identify a target. And this target can be, say, a client system that we've embedded several agents on, and so as it calls back, it knows where this information is coming from so we can track targets. Target may also be a web server. So say we own a web server that we can predict a particular target is going to visit. Well, we set this web server up with a particular target. Every time it gets hit by this particular person, then it sends us back and says, hey, this is the target. Agent, obviously, the stuff we're going to talk about for the rest of the day, all these different agents you deploy. We want to know which agents are reporting for which target, so this is how we distinguish between those two. There's an option to put some comments in there if you have some miscellaneous data. And then the next 3 things is where the tracking information comes in. So there's 3 different ways that this API communicates tracking information. One, if the agent has the capability of figuring out the lat, long, and accuracy by itself, it just simply reports that information back to the server, right? If it does not, if it has the ability to, say, conduct a wireless survey on the client side, it just shovels all that data back in this next form you see right here. Here's the operating system, here's all the data, you parse it on the client side. The reason on the server side, the reason I do it on the server side, or we do it on the server side, is because if there's parsing errors, at least we still have the data that we can chunk through it ourselves and figure out what was actually sent to us, right? And then if none of that works, or if the agent doesn't have that capability at all, we simply geolocate by IP. Now we all know that's not very accurate, but it's something. It's better than nothing, okay? So let's hop out of here real quick and take a look at what the framework looks like. When you first open it up, it looks like this right here. It says select a target to begin. Over here you have this list of targets. Here we'll select demo page. I tweeted it out last night for anybody that may have seen it. Hey, if you want to participate, go to the demo page. So you select your target here, and then you have the target locations of all different people that have visited. I had the HTML agent and the JavaScript and possibly the applet agent all built into that, and we'll talk about those in a second. And you can see over here to the left, you can select the target. It updates in real time, so as new targets are reporting, you'll see them in here. It's all Ajaxified, right? And then you have this filter for all the different agent types. And you can uncheck these and check these, and it'll show them or not show them. All right? And then down here, you've got, hey, here's my most recent hit. Here's my most accurate hit. So it's a good panel for analyzing all this data that the Honey Badger server is collecting. This is where the analyst spends his time. Okay, so that's the control interface. What's the real power, or the real power of Honey Badger comes in its agents, right? So these are the seekers tools. These agents are the seekers tools that we mentioned earlier. And this is where we begin to leverage all those technologies to try to reveal the locations of our target. All right, so we have two main types. One's web-based, and the other's client-side. I touched on those briefly. Web-based, you deploy them out to a web page or a web server. Client-side is something we get onto our target's machine, right? One of the base technologies that we're using in all of these different agents is the Google Geolocation API. Who's familiar with that? Okay. Well, when Google was doing the whole Street View project a while back and they got in some legal trouble there, that was kind of the beginning of this thing where they started collecting Wi-Fi access point information. Stuff that's public, it's out there, it's viewable, but they were pulling it down and storing it. They began to build this database, and then they released Android, right? Everybody has an Android phone. If you got your location services turned on, you are now updating, maintaining this database through your phone. Okay, so it's an incredibly huge database of all this information about access points. And the way we access it is, we give it a BSS ID, which is the MAC address of the AP, an SSID, a relative signal strength from where we're at. For every access point that we can see, Google triangulates your position and says, here's your lat long and accuracy. Right? This is the basis of what we're using. Now, the way we get the information to send to it is the real trick. But this is the technology that actually gives us the lat and long of where they're at. Accuracy is pretty scary. Typically, if you had 2-3 APs nearby, within 10 to 60 meters. And that's pretty darn close. Almost as good as GPS. Not quite, but almost. All right, so the first type of agents that we're going to talk about are these web server agents. Okay, these are the ones that are deployed on the servers or web pages. All right, we try to allure our opponent or the hider to this page so that they are confronted with these different agents that try to geolocate their position. All right, the first one is web HTTP. This is that worst case scenario where all they have is just a simple HTTP hit, and we try to geolocate by IP. HTML5, this is the HTML5 geolocation that's built into most of your browsers. If you've gone to a web page, you've seen a little thing pop up that says, hey, share location. That's HTML5 geolocation. I ask you to do that, but I don't give you the coordinates. I then send them to my Honey Badger server. Okay? And then there's a Java applet which uses the hardware on your system to do a wireless survey of your area and then sends all that information to me. I parse it, send all the AP address, all this information out to the Google Geolocation API, and then I locate your position. All right, I'm doing all that on the server side. Now, what BHIS is doing, one of the efforts we're making, we want to begin to figure out how to embed this stuff inside of your administrative GUIs for things like SSL VPNs or hardware devices that may be facing the internet, right? A lot of those are Java-based. We're trying to find unique ways to embed that because we feel like from a defensive perspective, this could be really useful information for a defender to know who's trying to reach out and touch my SSL VPN. Right? You can reasonably expect where your employees are at, but we want to give you a visual and give you some data to analyze and actually determine whether it's a valid hit or not.
So we started off with the three basic modules or agents that come with the Honey Badger framework, and we expanded upon it, and we went ahead and built 3 more pre-exploitation modules or agents and 6 post-exploitation modules or agents that are integrated into the Metasploit framework. So with these agents and modules, I guess, is synonymous at this point. Metasploit uses the term module to describe a piece of code that executes a specific purpose, and agent is what Tim's using to describe what reports into the Honey Badger framework. So we basically married Metasploit with the Honey Badger framework. The first module that we wrote stands up the basic HTML server. And it attempts to geolocate based on the different techniques Tim described, either using HTML5, HTTP, or JavaScript, or the web applet. And it kind of does it with some scary precision. And rather than just talk about it, I'll just show you the demo. Hopefully you can see that. But you go ahead and use the module. It's using the Metasploit basic auxiliary HTML server, so you can specify a URI path or SSL cert or whatever. Once you stand it up, it gives you an IP address that you can inject in an iframe or target someone with. If they browse it, it will try various different techniques to geolocate them. That geolocation will then report in to both the Honey Badger framework and the Metasploit console with the lat long coordinates. And that's what's highlighted up there, if you're in the back and can't see, is the actual precise lat long coordinates of the individual that connected. The next module that we built, also for before you actually exploit a target, is to build a Adobe PDF document that can phone home. And it uses the Adobe JavaScript to go ahead and both try to submit a form and try to launch a third-party browser. If you submit a form and you're only proxying your browser traffic, then it will escape and show your public-facing IP, which is the intent. It reports into the Honey Badger framework, and you can see that the user agent for this is not the browser, but the actual acroforms used by Adobe JS. The third and last pre-exploit module that is scaringly easy is the SMTP image. So most email clients actually render HTML just fine, and that's okay because we have a lot of HTML formatted text. But few actually ask for permission to go ahead and fetch images off a different domain. And so all we do is render a 1x1 translucent or white pixel on the image on a server of our choosing, so we can send in an email and get receipt that someone's seen it and what IP address they're seeing it from. So that wraps up the three pre-exploitation modules. But what's really cool and why we wanted to do it was the exploitation modules, so that we can now take within Metasploit or use the Metasploit framework to create exploits that then run our scripts post-exploitation. So you could create something like a PDF that, as soon as it successfully exploits a target, performs a wireless survey and then reports in. Or create a Java exploit that searches for all EXIF images and their geotags and then reports in. Or create an Excel spreadsheet that goes ahead and looks through your iTunes backups for geotag information. So the first is just that. It goes ahead and it does the WLAN survey. It enables the wireless card on Mac OS, Linux, or Windows, and does a wireless site survey, and then submits those results of that Wi-Fi site survey using the SSID, the BSSID, and the signal strength to Google to go ahead and get a specific location, and then it reports accuracy. So just a quick demo here. I have an active session. I go ahead and use auxiliary Badger WLAN survey. It's got a couple options there of where it's going to report into. I set the session I want to run it against, and it goes ahead and performs that wireless survey.
It is platform independent. That's all. You want to say that in there?
Tim just said it's platform independent. So it went ahead and found a bunch of wireless networks, and then geolocated based off of that to its precise lat long. And just to give you a feel for how late I was working on my presentation and also how precise it is, we were still working on this as flying in last night. So there I am at Chicago O'Hare on my connection flight trying to still make everything work and finish our slides. And it precisely located me right to the airport terminal that I was at. And you know, just because you probably don't believe me, I also took a screenshot of it. Pro tip here, if you're ever flying through an airport and you stick a laptop next to a window and start taking photos, you get assigned a personal TSA agent. Badger Preferred Networks is the next module, and what it does is it looks at the fact that Windows stores both the SSIDs for all previously connected networks in one registry key, and then stores with the GUI ID for that, in a separate registry key, it stores the default gateway MAC, which in most cases is also your BSSID. After exploiting a target, this one goes ahead and looks up that BSSID on wiggle.net. We have to use Wiggle in this case because Wiggle can look for single BSSIDs where when you submit to the Google API for a single BSSID, it just resolves against an IP address. But Wiggle is a free open platform and you can use it. So we just wrote a module so you can go ahead and query it for a BSSID. So it's just another auxiliary module. You set the BSSID you search. You also set the username and password you want to use, but I didn't put that up here, obviously. And it goes ahead and reports in the lat long of where that BSSID was last seen by Wiggle. EXIF find does exactly what it's supposed to do, find John McAfee. But it's also a very valuable tool in the fact that after exploiting a target, it will go through your photos, find EXIF tag photos, download those photos, and parse out the EXIF tag information to know your lat long coordinates. So no surprise here. I have an active session. I use it. To use the tool, I can set the path and how deep into the path I want it to recurse. And it goes ahead and downloads the specific images it finds and pulls the geocoordinates out of them. So this was the photo it just downloaded on the bottom right-hand corner of the screen of some cyclists. And then here's what it looks like in the Honey Badger framework behind it. It shows you where it reported in the image, and it's scaringly precise. You can actually see it's hard to point out, but you can actually see the stop sign in both photos, or the speed sign. And the next module or agent, we're still working on this, to be honest, but it scrapes your iTunes mobile backup and downloads both the binary plist and SQLite databases. And the EFF gave a great talk this summer on how much information gets actually stored in those that shouldn't be stored in those. And some of that information being geodata keys. So I think there's an app called Alarm Clock Free Best Magic or something like that, that for some reason when you first start up, it asks to use your location, and if you enable yes, it marks your precise geocoordinates and then stores them in a binary plist that gets archived on the phone and then in your backup. So all we do is go in and just download that plist, parse out the keys that look like they are longitude and latitude, and then report that in. Your browser does the same thing. If you use something like Maps, like Google, or if anyone still uses MapQuest, there's a whole bunch of URL parameters that have information in them, like lat long, geocode information. So all we did is wrote another module that goes ahead and downloads the Places SQLite database from Firefox, and then dumps that against known parameters that are geotag information. And so here, we're running against an active session. It's figuring out what platform and type you're running it against, and it figures out that you're also running the Firefox browser, what user privileges you have. It sees that you don't have root, so it just goes after the active user. And then it goes ahead and it downloads the SQLite database that contains your places that you visited, and then from there it parses out all sites that have geotag information in them. And then it reports it in to the Honey Badger, because it doesn't care. All right, so we were worried that we didn't have the word cyber enough in all of our slides. So on the next slide, we were helping the guys playing at home. Once we have geocoordinates, we can embraceify our cyber web 2.0 social media strategy. So there are quite a few web applications out there that have very Google searchable APIs that if you specify a precise lat-long coordinates, it will give you all the social media emanating from a radius around that specific point. And listed are some of these up there. So there's one tool that Tim released before at DerbyCon. We thought we'd flash it up here, but because it's incredibly valuable, it's called Pushpin. It scrapes all of those APIs for social media emanating around a lat long once you found it, puts it in a nice web interface for you to look at so you can see all the social media emanating from that point, and then it also places in a mapping tab. So,
This person here?
again, you can see how late we were at. So from the bottom of my heart, thank you, because I ran this thing about 50 times last night trying to find an appropriate comment to put in the slides, and that one finally popped. I will gladly buy you a beer later. And that pretty much wraps up our slides.
Let's, I'm going to take just a minute or so to kind of show you, since we're not actually lying to you about this, it really does work. If we go in here and we look at this and we want to pull out and say, I just want to see the JavaScript stuff, right? You start to click on these and you'll notice the accuracy varies, right? Some of it's very inaccurate. Others should be pretty accurate. What's going on here, people? Well, you can see the accuracy popping up here, right? Look at this one, like 30 meters, okay? So there I got a hit from somebody in the United Kingdom overnight who's obviously not here, right? Who hit this demo page in the middle of the night, accuracy within 30 meters. That's pretty useful information, right? Now this is more of the web agents. We go over here, which was a Shmoocon test with a capital. Let me check. If the internet connection is slow, it may take a second to load up, depending on whether or not we even got connectivity. Feel free to raise your hand for questions if you have any.
Yeah, question back there from the Navy guy.
Any concerns about the legality?
There we go, right there. Sorry, go ahead.
Any concerns about the legality of you putting code in someone's system?
Absolutely.
Absolutely, most definitely. And did you want to address that? I mean, that's absolutely right. So either have title authority or some sort of memo that says you're allowed to do that, right? Make it a part of the pen test. Okay, one of two things. Yes, these are us.
So there's a consent document, Tom.
Okay, no, that was JavaScript, right? So if you've ever gone to a website that pops up and says, hey, you want to share your location, the ones that are showing up on the demo page were those, right? So if you give me that information willingly, I don't see any legal information there.
There was also a memo. There was also a banner.
However, I did read an article not long ago that said that they're really considering the legal ramifications of aggregating the data like this, so that people can do exactly this. I don't think there's been any laws passed on it, but I definitely know that they're considering some of that stuff. Go ahead.
Do I have to give you all my data, or can I get my own Honey Badger server?
It is, here, let me show you. I'll give you the links to it right now. How about that? You can have your own Honey Badger server, Mark, okay? Now, the repo's still private, so if you try to go there right now, it won't work. I'm going to publicize it. I just forgot to do that before I came up here. Okay. All right, good. No shmoo balls. All right. All right. But that's it. If there are any more questions, anybody else got anything else? All right. Enjoy it.